Hi, I'm Talmadge Carr. I'm from Pleasant Grove High School, and my project is what kind of effects do winglets have on airplane wings? I've always been fascinated by airplanes and how the shape of wing can cause lift just by angling and the way it's shaped that it pushes air down, resulting in an aircraft to fly upward. As a kid, I always remembered to put the little flare that I noticed on airplanes on my paper airplanes because I thought it looked cool and thought it was a nice little detail to add. But I never really knew what they meant, so this year when I was asked to do a science project, this is what I decided to do. So the way lift is produced is this right here is the cross section of an airplane wing, the blue. The orange would be like the wind going by, and as the wind goes by, it follows the surface of the airplane wing, and it'll be pushed down because the airplane wing will have an angle of attack, which is just the way the airplane wing is set out. So if you notice when you put your hand out of the car window, if you just have it flat, your hand will go. But if you angle it back, then your hand will go up and down and so forth. As this air follows this path, because of the way it's shaped, you get high pressure on the bottom and low pressure on the top. And this air, when it gets to the back or to the end of an airplane wing, this high pressure over here will chase the low pressure on the top. And that will result in vortexes coming off the end of the wings. When I was a kid, I always just thought they were there for either looks or maybe they just made the plane go really fast. But as I grew up, I kind of put together that they probably had something to do with drag. So my hypothesis was that winglets would actually cause less drag because they would have smaller vortices coming off the back of the wingtips, resulting in less drag and higher speeds or fuel efficiency. So for my first experiment, I wanted to get a really general idea about how well winglets actually worked. So from just growing up, I learned how to make 3 different airplanes. I called them the Dart, the Glider, and then the World Record airplane. So what I did was I made 6 paper airplanes in total, two of each model, and then what I would do is one of them I would keep the exact same, and within a completely identical one, I would add winglets. So I had one as a control, and then I had one to compare it to. And I would throw these paper airplanes 30 times each, and then what I did was I graphed each one, and so I could have a visual result. Okay, so for my results on my first experiment, clearly the results were what I expected. The winglets had a very obvious effect compared to the conventional airplanes, and as I started throwing them, I was clearly seeing that that's what was going to happen. So for the Dart, the winglets on the Dart had an average of 5 feet more than the other one, than the conventional, excuse me. And for the Glider, it was 6 feet, and then for the World Record airplane, it was actually 15 feet. So it was very obvious as I was throwing them. I was just like kind of blown away. I did not think that it was going to be that obvious, but it was. So now that I had proven that winglets did have an effect on the airplane wing, or on the airplane, I wanted to know why. I decided to make my own wind tunnel. For those of you that don't know what a wind tunnel is, it's a way to visualize airflow around an object. It's commonly used for like rockets or supercars, so that they can see how efficiently their object is cutting through the air. So because I don't work for NASA, I had to build my own. So what I did was I had a box fan that was blowing air, funneling it through this tube with cardboard. And so as the air comes off of the fan, it's all crazy and it's not coming out straight. It might even be swirling around. So I used cardboard tubing that you would find like with paper towels. And I lined a ton of them up so that as the air came out, it would have to go through that and straighten out so that it could represent straighter airflow of like an airplane. So then what I did was I made my own fog machine because I don't own one of those either. So I used dry ice inside a bowl of water, boiling water actually, so that I could make the CO2 coming off of the dry ice more dense and easier to see in the wind tunnel. And then I closed it off airtight, and then I took a see-through tube and put it into the wind tunnel right here. It follows back here. And so then as the wind is coming out, it's shooting out CO2 from the dry ice so that as the wind is passing by the object, my wingtips that I had made out of wood, then you could see how the air was flowing around this wingtip. So then I could get a better idea of maybe why the conventional wingtip wasn't working as well as the winglet wingtip. So behind the object that I had in this wind tunnel, I had a grid that could measure how big the vortices off the end of the wingtip got over time. So for the conventional wingtip, you can see that over time, I went between 0, 1, 2, and 3 inches is where I measured. So over the time, at 3 inches, it was the vortice diameter-wise was 1.5 inches. That was way bigger than 1.5. And then for the winglet one, compared, it was only a 1/2 inch. So over time, from the conventional wingtip to the winglet wingtip, the vortice for the winglet was a lot smaller than it was for the conventional wingtip. So for my conclusion from both my experiments, I found that winglets had far less air resistance because the vortices were smaller and they were disrupting the air a lot less, cutting through like a sharp knife compared to a dull knife. Which resulted in better fuel efficiency, which could make the plane travel even farther than before. And what I found from the wind tunnel experiment, as a little bonus that I didn't realize that I was going to find, was that watching the air, I noticed that it twirled in towards the top and the center of an airplane from the wingtip, which puts more air down, which could take away lift. But because the winglets for vortices were so much smaller, that wing didn't come back to the center of the airplane, which results in that plane having more lift. So planes having winglets can fly farther, they can hold more luggage, they can collect cargo and such. And so winglets are altogether just incredible.